Well, good morning, everyone. We'll go ahead and get started with today's online training, specifically looking at gas turbine surface preparation. For many of you who do other applications, of course, these kinds of surface preparation skills are certainly helpful. So we're pleased to have over 100 people joined on today's online training. My name is Scott Drennan. I'm the Director of Gas Turbine Applications for Convergent Science, and today pleased to have Dr. Gaurav Kumar, who's Senior Research Engineer, works with me in gas turbines for Convergent Science, and he'll guide you through the webinar. So today's webinar will take about 2 hours, and you are welcome to ask questions during the online training webinar. And there's a little ability to type in your questions there on the GoToWebinar tool there at the bottom. Just want to make sure that you know that your questions can only be seen by Convergent Science employees. While Gaurav's going through the training, I'll do my best to try to answer your questions live. But if by some chance I'm not able to get to that while we're talking, we'll certainly make sure that you get a response. And Gaurav will try to answer some perhaps common questions that we see during the training, at the end of the training. Let me also point out that we do have several other gas turbine online trainings happening. So every other week, we're going to be doing this 2-hour format of walking you through some of the key features of doing gas turbine modeling and Converge. And the next one is on February 14th, Valentine's Day. And that will be looking at premixed combustion specifically. We're very pleased to have also, after that next training, is Hasti from Purdue will be presenting his work that he's done with Converge using a premix flame in that premix webinar for the last 30 minutes. So we look forward to that. I'd like to also point out to you that we have a recent white paper that we've done on SAGE, our detailed chemistry solver with LES, specifically looking at incorporating turbulent chemistry interactions using detailed chemistry and proper mesh resolution with LES. And you can find that by looking on our gas turbine applications page here, and just under resources, there's a little icon here for white papers. Please click on that and give it a read and let us know what you think. There's a number of online training resources that are available to you. And I want to make sure that you're aware that the slides that Gaurav will be using today are available for download on our download site, where we have a number of other sets of slides. So we have specifically the set that Gaurav will be talking about today is the surface preparation for gas turbines using CONVERGE Studio. We also do have basic and advanced gas turbine training slides. Some of those we'll be using in future webinar or online trainings. And certainly we have example cases and quick start guides to get you up and running quickly. If you don't have access to our website, please do register on our website, and we'll grant you access, and then you'll be able to see these tools. We do also, I'd like to mention that we do have 2 users conferences this year in Europe, in Bologna in March. We'll have a users conference, and we welcome people to attend. Attendance is free on both of these user conferences later on in the year. In Detroit, we will have, oops, excuse me, I've got the wrong one on there. That'll be in Madison, Wisconsin, later on in the year. So please do check those out. And like I said, attendance is free. Now, I'd like to give just a little bit of an introduction into Converge for gas turbines for those of you who aren't aware of us or know much about us. We've been doing this for quite a while now, and there's some key aspects about Converge that make it quite advantageous to gas turbine combustion modeling. First of all, meshing certainly is complex in gas turbines and takes too long. Converge's ability to automatically mesh complex geometries really does help speed along the design process. Another key point is that mesh requirements are important for LES combustion. As I mentioned in that white paper, we talk about that. And adaptive mesh refinement and automatic meshing really do give an advantage of being able to resolve the flame front such that detailed chemistry can be accurately applied. And one of the key things that we do get with that is we get emissions, and we get ignition and relight, lean blow off, and flashback are all capabilities that are not often addressed well with conventional CFD codes. And CONVERGE does very well with those. So if you're looking at predicting CO and NOx, or also predicting NOx with a fast FGM approach that we'll talk about later in future trainings, those are all certainly available. And then certainly we have advanced atomization as well for gas turbine atomizers. So with that, I have one more slide. I'd like to talk a little bit about adaptive mesh refinement, just to gauge or let you know what, for those of you who aren't familiar with it. CONVERGE uses a automatic meshing technique where you have a base mesh size, and then you use adaptive mesh refinement to refine the mesh when and where it's needed. So we look at things like velocity and temperature and species, perhaps even the Y+, and we add cells in, or adaptive mesh refinement adds the cells where they need to be. It's important to know that you have full control over the mesh, and that we also find that quite often we get similar accuracy with a lot fewer mesh, or with a lot fewer cells than with other CFD codes. So please do give that a try. And with that, I'll now pass it over to Dr. Gaurav Kumar, and he will take you on for the training.
Thank you, Scott, and good morning, everyone. Thank you for the introduction. My name is Gaurav Kumar. So as you have seen, today's talk is going to be on surface preparation with CONVERGE Studio. So this is part of the webinar series. So these are the following topics which I'm planning to cover today. I will start with the CONVERGE layout for the CONVERGE Studio. I will go with different modules in CONVERGE Studio, which is the case setup module, chemistry module, Congo, 2D line plotting module, 3D post processing. I will also briefly go over what are different docks in CONVERGE Studio, mouse control options. Then I will go over boundary and flagging. Flagging is a term that we use specific to CONVERGE. It's nothing but putting triangles to certain predefined boundaries. I will briefly talk over that. Then I will directly jump to creating a swirling dump combustor, and this will give you a hands-on on creating a sample geometry in CONVERGE Studio, and swirling dump combustor, which is commonly seen in gas turbines. So this was a good example to look at. After that, I will go over surface defects in much more detail. I will outline what are the surface defects, or common surface defects found in geometries. And after that, I will follow with what are the different cleanup tools available in CONVERGE Studio, and how to use those tools to remove certain or most of the surface defects. So what is CONVERGE Studio? It is graphical pre and post processing processor that is included with the CONVERGE solver. This is available for Windows or Linux, although we do have a version for Mac available, which is unofficial though. This contains modules that can be accessed by buttons in the lower left corner. This could be, these are the case setup module that we are looking at right now. Then following that is a chemistry module, Congo module, line plotting, and a post-processing 3D. So you must keep in mind that this is only a pre-processor and a post-processor. That means that once the case is set up, you take it out, you can export the input files, and then you take it to your HPC and run your case. Although we do have a function to run serial version parallel directly from Studio, but that's not commonly used. So in CONVERGE Studio layout, in the case setup, on the very left, you will see viewing direction. So if you're looking at a geometry in the graphical window, you may want to orient the geometry in a certain orientation. So these are the different predefined directions which are specified. And then on the left, you have a geometry dock, which is used for surface cleanup and for boundary flagging. To the right, you are seeing right now is a case setup doc, which will be used to set up the input files. This doc is indeed a tab browser. You will see case setup, view or diagnosis doc. Right now, diagnosis doc not open. Otherwise, you will see multiple tabs in this doc. On the very center, you will see different output panes. You can see message log, case setup issues, and import log. And these are the different panes which print out outputs from CONVERGE Studio in different operations. And on the very left, I've discussed there are different modules, like the case setup module, which you're seeing right now, and then chemistry, Congo, and post-processing 2D or 3D modules. So in the case setup module, you can set up and repair surface geometries, and also it's very important in terms of setting the input files. Because CONVERGE Solver CONVERGE Solver creates the mesh automatically at the runtime. In this module, we never create the mesh. We just even when you're setting the input files, you tell CONVERGE Solver how to create the mesh. You give it certain parameters, but you never create the mesh. So this module, keep in mind that this is not for creating the mesh. So when you're working in this module, there are different files that you will come across with. One of the common files, which is CVG file. Consider it like a project file. You start working on a project. You are in between, and then you want to, if you want, then you can save it as a CVG file. And then the next time you come in, you can bring that up, and then you can pick up where you left off. So this is a file which is very specific to CONVERGE Studio. Note that this file cannot be used by CONVERGE Solver. This is only for CONVERGE Studio, and also again other programs cannot open a CVG file. It's a binary file. So and then finally, when you're done with that CVG file, when I set up the case, you export your input files, which are typically .in or .dat files, and are in ASCII format. The next module is the chemistry module, which offer different chemistry tools, 0 and 1D tools, mechanism reduction, mechanism merging, and mechanism tuning. Congo module is for setting up a design of experiments or genetic algorithm setup, which is used a lot when people want to optimize geometry. Line plotting module is for visualizing the 2D data sets. When CONVERGE runs, it prints out a 2D and 3D data sets. 2D data sets typically could be volume average or surface flux, these kind of quantities, and you can use the line plotting module to create the 2D plots that you need. This is very useful to monitor as your case runs. You may want to look at certain variables to see the progress of the run, and you can use that. And this module comes out to be very handy for doing that. Again, that's a file which is associated with this is called a .psp file. It's the same as a CVG file. It's almost like a project file. You can create a bunch of plots, and then you can save it as a PSV file, and then you come back again. You can load that up, and it will open up as if you're working on your previous setup. Post-processing or 3D module is for converting your 3D data sets into the format that you want to visualize it. So if you want to visualize the data set into NSI, field view, GMV, text plot, or paraview, you have different options, and this is for converting the 3D data sets into different formats. So whenever you're working in CONVERGE Studio, there's a good set of documentation which is available, and it can be accessed through different ways. One of the options is to press F1 whenever you are in a certain place. It will open the relevant help section. Alternately, you can also go to help on the very top, and say help, and this will open the help module, and you can search for, or you can look at the index. You can also do a control F and search for a parameter name. Specific, this will be useful if you're looking for a specific parameter name in input files when you are doing a case setup, and this everything would be linked so that you can click on that and it will take you to the right place. No, so now that being said, now how do we start a project in CONVERGE Studio? So you have open CONVERGE Studio fresh. So how do you start a project? So um, uh, so one of the first thing you will see is, as you launch CONVERGE Studio, it will open a dialog box. So you may have unchecked it. If you have not unchecked it, this splash screen is open up every time you open up CONVERGE Studio, and then you have an option to start a new project, or you can open an existing project. Same options are available through the file menu. You can say new or open a project. And both of this will ask you to bring up a CVG file. So these are looking for, this will look for was the CVG file, and not the .in or .dat files, which are typically used to run a case. Now let's take a look at different docs in CONVERGE Studio. I briefly mentioned about docs. So if you are looking at CONVERGE Studio, as if you're looking from the top right image, you will see I've highlighted two docs, and the different docs are outlined here. On the left, you typically see the geometry doc, which you use to manipulate geometry, make measurements, do boundary flagging. On the right, you will typically see diagnosis doc, case setup doc, or the coordinate cache. Although these are docs, you can dock them, you can undock them. Like, say, you can bring up the case setup doc outside, and if you want, you can bring it up on this side. Typically, these are tabbed, and I like to keep these docs on the right hand side, my geometry docs on the left hand side, and the case setup docs is very useful for setting up the physical models, essentially setting up a case setup. There's another doc which is coordinate cache, which stores the coordinates and vectors from the geometry. So whenever you make some measurements, it's so you want to make some measurements for injector location, or where you want to put the sources, you can store the vectors and you can paste it in when you are in the relevant section. And lastly, we have the view options doc. It is to toggle the boundary visibility, changing view angles, doing the clip plane if you want to look inside the geometry. Now we have different output panes in CONVERGE Studio. Output panes are display messages regarding geometry operations, or import operations, or case setup issues. So there are three different types of output panes. One is message log, import log, and case setup issues. And this you will see typically in the center on the bottom, that you have different message logs, and each of them correspond to different types of outputs. A message log will typically display information regarding geometry operations, so whatever operations you have done. So if you want to make some measurements, it will be displayed here. Import log displays information about imported .in and .dat files. If there is an error, or certain files are missing, or there was unreadable characters in those files, it will be written out in the import log. Case setup issues doc will display warnings for when you're doing the case setup, and this all are linked warnings, so that you can click on that and it will take you to the place which generated the warnings. Now, how do you import a surface file? I already talked about how you open a project file. That's opening a .cvg file. But say if you want to start afresh, and if you want to import a surface file, and start from there, and then you have different options for importing a surface file. The very common format which is used in in CONVERGE Studio is the .stl file. STL files, as you know, that are generated from a CAD program. So if you're working in a CAD tool, you export an STL file, and that is the only file CONVERGE can read, which is generated from a CAD program. So remember, when you have a gas turbine geometry, you exported an STL file, and that's what you can read in CONVERGE Studio. So when you're working in CONVERGE Studio, you have an option to export is in a .dat file, and that's if you have that available, you can also read that in, and that's what it is. It is shown here. You can import an STL or you can import a .dat file. So when we are importing an STL file, CONVERGE gives an option to change the units and to specify a tolerance for stitching. Changing units is useful because sometimes the geometry are generating in different units. So you have an option to change the unit. You can also change it later too. But if you want to change right away, you can use the scale from option. You can scale from either, if you don't want to change it, just leave it meters to meters. You can change from inches to meters and so on. And also there is a tolerance which is needed for the STL file when you are importing it, because STL files triangles are not connected with each other, so you need to specify a tolerance, and this will be used to stitch the vertices when they are read in. And I will recommend that you can leave it automatic tolerance unless you know what you're doing. In that case, you can use a user specified tolerance. So when you're working in geometry, it's important to move the geometry around. You want to zoom in, pan, and that's where the mouse control option comes in. And we provide different ways of controlling the mouse. You can do rotate, zoom, and pan with your mouse buttons. And there is the option to use the control key or not using a control key. I will recommend using a control key. Otherwise, say if you are in the geometry and if you accidentally rotate the view, if you really wanted to just remain in that view, in that way you are safe in that you won't accidentally rotate the geometry. This you can set up by going through in the geometry dock, going through options, mouse, and you can choose the way you would like to configure your mouse. Now, let's go to tools for entity selection. I've been talking about geometry, and each geometry is made up of entities, and we are talking about three basic entities: vertices, edges, and triangles. Like in this geometry, you'll see that essentially that's what all geometry is composed of. And when you want to manipulate the geometry, you want a way to pick up different entities, and I will talk about those. But before that, I want to talk about a feature which is very useful in CONVERGE Studio for picking those entities, and which are called boundary fences. And what are boundary fences? These are edges which flag the sharp features in the geometry. And typically these would be highlighted in white. Remember, these are temporary borders between sections of the surface. These can be created or removed as many times you would like. These can be created automatically based upon a sharp feature criteria. Say in this case, I've used say 135 degrees. So all edges which are shared by two triangles which meet an angle less than 135. Those would be flagged in white. It can be of user choice. You can do it as you like. You can select an edge and make a mark a boundary fence. Remember that these fences are not needed by the CONVERGE solver. This is only for geometry manipulation in CONVERGE Studio. And essentially, once you have flagged these, when you have created these fences, this will help you to pick up different entities, and I'll talk about that in the following slide. So this will help facilitate picking up vertices, edges, or triangles, and how you pick those. And so every time you have a pick option, you can choose pick by boundary fence, and this will allow you to use the boundary fences in picking actions. So creating the boundary fence, let's talk about, there are two options. Either you can use automatic or user choice. For automatic, go to geometry, boundary, find clean. you will see an option to provide the sharp feature criteria, which is nothing but an angle between two triangles. Something given like this, and you specify this angle. The default is 135, and this will flag all edges which is shared by two triangles making angle less than 135 degrees. You can also create boundary fences by user choice. Go to boundary geometry boundary fences, and then you can mark fence and unmarked fence based upon a user choice. So now let's talk about entity selections. And entity selections is done through Objects Toolbar. Objects Toolbar is a toolbar which is on the very top of CONVERGE Studio. This you will see vertices, edges, and triangles, and you will see different types of selection options. So the way to use the Objects Toolbar is to first select the entities, which entity you would like to select, vertices, edges, or triangles, and then you see how you would like to select them. And typically you will see a boundary fence option, one of them. There are other ways of selecting it. And the third one you will see is what pickup tool you would like to use. Most common is you use a cursor pick, although you have a box picks or a circle pick which is available. So I will go over each of these, each of the entities in the Objects Toolbar. Say if you are trying to pick up an entity vertex, so you will go to Objects Toolbar, you will select vertices, and you will see different selections options available. First one could be any, in which you can pick vertices one by one. Like in this case, you are trying to pick up using any pick. I can pick as many vertices as I would like. Again, not very easy, but sometimes it's easy if you want to just pick up a few vertices. If you want to pick up a bunch of vertices which lie along a boundary fence, you can choose option boundary fence, and it will pick up all vertices on the boundary fence. You can also pick up vertices and an open edge. An open edge is an edge which is shared by only one triangle. Typically, all edges should be shared by two and only two of the two triangles. If it's shared by anything less than two, in this one, it will create a hole in the geometry, and we call it an open edge. So, but open edge, you can use that to pick up vertices. Again, you can use a cursor pick, you can use a circle pick, or a box pick. And the similar options are available for picking up word edges in the Objects Toolbar. You can pick up by any, by arc, which will select edges lying along a common arc. You can pick up by an angle, which will pick up edges, consecutive edges, which is connected, consecutive edges which have the same angle between the connecting triangles. Also, you can pick up edges based upon a common open edge or a boundary fence. Different pickup tools are available: cursor, box, or a circle pick. Now, if you are in Objects Toolbar for picking triangles, there are different sets of options available. You may have seen that as we change entities, there are different the selection options changes. And in entity selection for triangles, you will see a whole new sets of ways of selecting triangles. The first one is pick up any, in which you can pick triangles one by one. Pick up by an angle, in which it will pick up all connected triangles which are normal vectors intersecting less than an angle of 135. So you can specify, you can click on one triangle and it will try to select all triangles which satisfy this criteria. You can pick up by a surface, in which it will select all triangles on a connected surfaces. Say it's in gas turbine, mostly all surfaces are connected. So if you pick up by surface, it will pick up everything. But say if you are doing a flow past an airfoil, you may have an airfoil within a bounding box. So you may have multiple disconnected surfaces. In that case, you can pick surfaces one by one. You can pick up by boundary. Once you have boundary flag, I'll talk about this in shortly. When you have boundary flag done, you can pick up triangles assigned to a certain boundary. You can pick up by boundary fence, which is the most useful and which is the most commonly used. Say if you have drawn a boundary fence like this, and say this edge is not flagged at a boundary fence. And if I click on a triangle, it will propagate outside and it will select all triangles lying enclosed within the boundary fence. And these are all the selections of triangles that will be made after you have clicked on any one triangle. You can also pick by a fence neighbor. This will, you can select a boundary fence that will share all triangles which share a node with the boundary fence. It's useful if you want to select all triangles which are neighboring a boundary fence. Again, different pickup tools are available of cursor, box, or circle pick. Now, let's talk about boundaries a bit, because we shortly would like to show how to create a swirling dump combustor. So I will give a very brief introduction to boundaries. So this one on the right, you are seeing Converge in the case setup module. I have a geometry which is our LDI geometry here, and I'm in the geometry flag under the geometry flag section. And so boundaries are nothing but a group of triangles which are assigned a name. And one of the most common reasons that you may want to create multiple boundaries, because we want to assign different boundary conditions to these triangles. You could have inflows, outflows, walls with different temperatures, shoulder. There are multiple other reasons, and to create different types of boundaries, you may want to do different sorts of embedding. You want to create regions. So there are whole sorts of benefits of creating different boundaries. So once you have created different boundaries, you can select different triangles and assign them to different boundaries. Each boundary should have a unique boundary name, and by default, it has a unique boundary ID. But once you have flagged triangles to different boundaries, it also helps in setting up the geometry. You can use that. You can use boundaries to hide certain boundaries so that you can easily look inside the geometry and perform different repair options. You can set up different boundary conditions. When you are in the case setup in the case setup doc, you can do grid refinement, setup of volumetric regions, and there are multiple ways you can exploit boundaries. So once you have started a case fresh, all the boundaries typically would be assigned to boundary ID 0, which default name is not assigned. And you want to make sure that when you export the case, there is no triangles left in this not assigned boundary. Like in this case, there are no triangles left behind in not assigned. And if you have any triangles left in boundary ID 0 or not assigned, Converge will complain, and so you have to go back and make sure that you flag it correctly. So in order to flag, you have to create boundaries first. And to create boundaries, you go to Boundary, Flag, and click on this plus option. This plus will ask you to create boundaries one at a time, or you can create multiple boundaries. Once you've created the boundaries, you can right-click on it to change the boundary names. By default, the names would be boundary and followed by a boundary number. If you are creating boundaries one at a time, you can choose to put your boundary name right away. If you create multiple, you can create the boundaries and you can right-click on the boundary names and you can change the name as you like. So once you have created different boundaries and you have put the names you would like, it's time to flag triangles to boundaries. And in order to do that, we will use the boundary fence option. So we'll go to Boundary, Flag, and then we'll start selecting triangles by boundary fence. Say in this case, say they have picked up a swirl air inflow. I will click on a triangle. It will select all the triangles, and it will select a swirl air from the boundary flagging menu and say apply, and it will flag all these triangles to swirl air, and so on and so forth. And once you have flagged those triangles, you can go to View Options. and from there you can show and hide geometries as you would like. And there is a shortcut also available for showing and hiding geometry. You can select a triangle and press V to toggle the boundary visibility. There are different other useful viewing tips. You can right click on your geometry in the visualization window, and you will see a set of options which is available. You will see view at, which is used to set the center of rotation for the geometry. If you want to rotate about a certain point, which is very useful, you can select a bunch of triangles and say hide selection. This will hide those triangles. Isolate, you can select a group of triangles, and you can either use Control L shortcut or select isolate, and it will isolate those triangles, hiding everything else. The redisplay would show up all the triangles, and again the shortcut V is also always available if you have already flagged boundaries. Select a triangle, press V, and it will hide the boundary. Press V again, it will unhide it. Now let's go to creating a simple swirling down combustor. For this, I will jump to Studio and try to give us some sort of hands-on. So I have CONVERGE Studio open, and say imagine that you have already created a swirler in your CAD model, and you have exported it to an STL file. So what I will do is I will go to File, Import. I will import an STL file. So I have saved it in a certain location. Say if it's swirler geometry, I will import it. As you see, I'm using an automatic tolerance, and since already I know that it's in meters, I'm not converting it, although I have different options available. So now my swirler geometry is imported. Now this is the swirling hub, and I would like to create a dump combustor on the positive Z direction, and definitely want to create some inflows here too. So this will give an opportunity to showcase some of the features in Studio. So I want to create certain geometry, and if you look at this menu here, there's an option Create, and I can create different entities. I can create triangles, edges, vertices. One option is to create a shape. I can create a cylinder. I can specify the center of one end and the center of the other end. Say in this case, I will put say 0, 0, 0. I will put a diameter of say 0.100 millimeters. I will create another center at say 0.25, and I will put a diameter of 0.1. I'll pick up the vertices. This will show how many vertices are created on the perimeter. And by doing this, I've created my cylinder. And I can also do edit, undo, which will undo this geometric creation. And I can create. If I say triangulate to center, all it did was triangulated these flat faces to the center. Now, if you look at this face is actually hiding the inlet. So what I'll go is I will create a boundary fence, and you see there's a shortcut for creating the boundary fence. Alternately, I can go to Find Boundary, Find Clean. I can clean my boundary fences. I can recreate it again. Okay. Now I want to delete this face, and I will create the face so that this inlet is not blocked. So I'll go to Repair, Delete. I'm selecting triangles, and you see as soon as I select different delete options, my entity selection changes smartly. Since I'm deleting triangle, I cannot pick up edges. I have to make sure that I pick up triangles. And I'm picking up triangles by boundary fence. I will click on a triangle. It will select all the triangles on the boundary fence. And so just to showcase, I've pressed Escape to hide all of them. And I will select triangles by surface, and it's going to select all these triangles. I can say hide selection. This will show things inside easily. So I will go to Repair, Delete Triangles. I will by boundary fence. I will delete it. Say Apply. Now see, it has created an open edge, and open edges are always marked in yellow. I can right click, redisplay, And I want to create triangles between these two open edges. So I will again go to create. I want to create triangles by lofting edges. And so I'm going to loft these two sets of edges. Now the question is, how do we pick those edges? The way I'm going to pick them is I will show one option to pick up by open edge. I can also pick up the second set of edges either by an open edge, or I can show you another option by pick up an arc. Either way, the purpose is to select it, and these are different options available to facilitate the selections. Which option do you choose does not matter as long as you pick up the right entities. And now I have created these new triangles. Now these holes are not, this is not blocked off. A flow can go through this, go past the swirl veins into the dump combustor. Now, if you want to create an inlet, I'll go to create. Again, I want to do the same thing. I want to pick up by open edge, first set of edges, second set of edges, and in which order I choose does not really make a difference. And once I've created this, I will go to diagnosis doc, which is the doc which can access from here. We alternately you can go to view diagnosis doc if this doc is hidden. I will check for errors in the triangle. You see, and I have I don't want to really select check for aspect ratios. My geometry looks clean. I can look up the normals in the geometry, and by default, all normals of the triangle tend to point towards the fluid domain. If you look at these normals, these are really pointing outside of the fluid domain. And if I had checked normal orientations, it will have complained that a lot of normals are not correct. And again, all triangles which are affected by those are highlighted in magenta. I will clear it. I will go to transform normal, and fixing the normals is the most easiest thing you can do. You can select any triangle and say apply. It will make all normal consistent. It make it consistently pointing outside. I want to make it consistently pointing inside. I will click again, and it makes all normals point inside. Now it's time to do some boundary flagging. I can go to flag. I will create a bunch of boundaries. I can create boundary 1, but that's not a good option. I can create, say, multiple boundaries at one time. Say starting boundary 2 and 5, and to create a bunch of boundaries. I can hide my normals from here. If you see my boundary fences are already drawn, I can, again, remember, I can draw them, redraw them anytime I like. So let's start assigning these triangles to different boundaries. I will start from boundary ID 3. I will call it inflow. Okay, and so I will select. Now I'm going to select my boundary fence, which is the most common thing I use for flagging, say inflows. And also I will go to in view options. What I will do is I will hide my inflows after I've selected it. I've flagged it. Okay, I will put, say, combustor. Combustor, and I will hide my combustor. So this is outflow. I've flagged my outflow, and now I can go fancy with the swirler. I can do a box select. I can assign it to one boundary, or if you want to unassign it, you can always select and say not assigned. And also, say if you have assigned it to a boundary ID 1, and what if I delete this boundary? So if I delete this boundary, what happens? These triangles are not deleted. It's nothing but these triangles will go to not assigned. Okay. So now if you want to separate out the swirler hub, so if you want to separate out the swirler hub, say boundary fence, I will select to boundary ID 2. I've selected the outer swirler hub, say inner swirler hub. And I will create one more boundary, and say I will call it swirl veins. And I can do a box select everything, and put it in swirl veins. Maybe I should have put this boundary fence, and I will put this in this boundary, boundary 6. So Now, this is all the steps that are needed in creating a swirling dump combustor, and now it's time to set up the boundaries. Set up your case. You can go to case setup and begin case setup, time, apply, and it's time to set up your case. And this is how simple it is to create a simple geometries in CONVERGE Studio. It's a very streamlined process, and this tools gives you a very a strong with a strong capability in assign flagging triangles. Now, I will go back to my slides, and this is all I have out discussed. And I've created swirler, inlet, front walls, and exit. Again, I've already out discussed all of these, so I will quickly go over these. I created a cylinder. I created a boundary fences. If you remember, I went to boundary fine clean. I created boundary fences. There is a shortcut available on the top corner. And remember, boundary fences are created in white. These are not used by CONVERGE solver. These are only for picking up triangles. I use the entity selection toolbar. I use triangles. When I pick in triangles, I use by boundary fences. I use different options too. I use cursor, box select. When I was creating triangles between two loops, I went to create triangle loft edges. There are different other ways of creating triangles. I chose loft edges for this case. I selected two sets of edges. The first set was say the outer edge, and the second is the inner edge. I have used by pick up by open edge by arc, whichever you would like to use. Okay, and also in which order you select these edges does not really make a difference. I created the front wall, then I created the inlet walls, and then I went to normals. So I did diagnosis. I found that there's a bunch of normal orientation problem, and I fixed those by going to transform normals and say I select on a triangle and propagate from a single triangle. Essentially, you can click on any triangle and it will propagate to all connected triangles and to make the triangles normal consistent. For my case, it was consistently outside. In this case, consistently inside. If I click it again, consistently outside, and if I check my normals now, it will not complain. Although if I check this, it will complain that it is actually pointing outside. So it's a good to have this check too. If you want to make it fixed again, do this, and you're all set. Now, after that, I created a bunch of boundaries. I flagged triangles to different boundaries, and in order to picking those triangles, I picked by boundary fences. And at the same time, I was using view options boundary, and I was hiding boundaries as I was creating them. I created outlet, I flagged outlet, combustor walls, front wall, and then for flagging the swirler, I have different options. I can flag the whole swirler to one boundaries, if I can flag outer hub, inner hub, swirler bins to different boundaries, and it's your choice. If you're the way you would like to configure your boundary, it really does not really make much of a difference, even if you have flagged all threes to the same boundaries. It's the way you would like to set up. Say if you want to put up different boundary embeddings on the three different walls, then you may want to split those boundaries into different boundaries. So it's totally upon the user the way you like to configure the case. So after I've created this, I was not really left with any unused boundaries. Say if I had this unused boundary left, I could have deleted this boundary, and so in that case, I really want only boundaries which are used in this current simulation. Okay, there's a way to reorder the boundaries. Say, really wanted to make sure that inflows and outflows were actually sitting together and they were on the top. See if I can move, drag, drop. Inflow would move to the top and everything would be moved down. I can reorder boundaries. Sometimes reordering boundaries is useful so that it just looks nicer. You have inflows, outflows all sitting on the very top, and then you have different boundaries, and you may want to order them in a certain way. So this tool is very useful in that. And So once you have done that, if you remember that if you do a right click, you can change the boundary names. So you right click, you have an option to change the boundary name. If you double click on it, it will give you an option to set up the boundary. And remember, just calling an inflow does not make an inflow. You really have to go to boundary setup and call it as an inflow. And that's what makes an inflow. Okay, and so now we have looked at how to create a swirling dam converter. Not all geometries are going to be this nice. Geometries exported from a CAD model typically have some certain defects, and it's important to know what are the common defects that could be present in a geometry, and how to address those, and and how to use CONVERGE Studio tools to fix those defects. So let's talk about defects. We categorize in CONVERGE defects into two different categories. One we call critical defects, and the other set is non-critical. Critical because it will prevent CONVERGE solver from running, and non-critical, they are not very important to clean them, although sometimes user may want to address those, but it's not important. So most of the time I do not address the non-critical defect. It does not really affect the performance of CONVERGE, but it is needed sometimes if you want to avoid certain problems like long stretch cells created between narrow gaps. But most of the time, it's not important to address the non-critical defect. So what all fall in critical defects? Intersections, open edges, non-manifold edges, and normal orientation. Under non-critical defects, we have aspect ratio, small angle, a small area, overlapping triangle, and isolated triangle. And I will go over all these defects one at a time. So before I go there, I will be talking about CONVERGE Studio. So let's kind of take a look at CONVERGE Studio again. If you remember, on the left, we have Geometry Dock. You can open Geometry Dock from View Options. You can also do Control+G. On the right, we have the Diagnosis Dock, which I will be using a lot when you're talking about surface defects. Again, you will see different defects option to check or uncheck them in the Diagnosis Dock. Then we have the Message Log, which is pertinent to, this is where CONVERGE Studio will print information for any operations you do in the Geometry Dock. And remember that Diagnosis Dock and Message Logs, these are all tabbed. So you may be in port log, and if you want to look at Message Log, you have to make sure that you change the tab. And so is the Diagnosis Dock. So what's the step involved in diagnosing the surface defects? You open the Diagnosis Dock, you select what are the different defects that you would like to address. In this case, intersections, open edges, non-manifold, and normal orientation. These are the typical critical defects, and one is suggested that you should always check for these problems. And all the problem triangles will be listed here, and they will be categorized under intersections, open edges, non-manifold edges, and normal orientations. Once you've done that, you see find, and every triangle will be listed here. So what are intersections? Intersections are created when triangles literally pass through each other. Like in this case, this is a critical defects. So how do you find intersections? So you are in Diagnosis Dock, make sure you click intersections and you select, say, all intersections. And once you say click find, it will CONVERGE Studio will look up through all the geometry, and it will show all the triangles which are intersecting, and it list on the problem triangles. And now you have an option to select these and say show. It will show only the intersecting triangles. If you show by boundary neighbor, it will show along with some of the neighbors, and which is useful if you want to look at the geometry, get some perspective. It's useful to have some of the neighbors turned on, and usually it's like no neighbors which are two steps away. So the connecting triangles and the triangles connecting the connecting triangles, and all the triangles which are affected by intersections are highlighted in magenta. Now, open edges, again the same methodology. These defects are critical. an open edge by definition is an edge which is shared by one triangle. Say in this case, this an open edge which is shared by only one triangle, and open edges will create a hole in the geometry. Like say if you have two sets of open edges, if you have created two sets of distinct hole in the geometry, uh, this is how an edge should look like. An edge should be shared by exactly two triangles. This is not acceptable, this is not acceptable. And this what you typically would call it a non-manifold edge, which is shared by more than two edges. More than two triangles. In order to find an open edge, we go through the same process. On the diagnosis doc, we'll select open edges and we'll say find. All open edges would be listed. You can say select and show. It will show up only the triangles which are affected by the open edge. And if it says show by neighbors, it will show the triangles along with the neighbors. Again, all the problem triangles, see this is the problem triangle which have an open edge, would be highlighted in magenta. Non-manifold edges are edges which are shared by more than two triangles. So this edge is shared by three triangles. It can be shared by more. So these are typically created, say if you have accidentally left behind a solid part of the geometry. So if you are doing just an aerovolley, if you have left certain solid parts in the geometry or a thin walls lying somewhere, this will typically create an open edge. And it's important we remove this unless you are doing a conjugate heat time for transfer problems. In that case, open edges would be created, and there are ways to address those too. So open edges would be highlighted in purple, and you'll see that it's not magenta, it will be highlighted in purple, and then you can turn on and off highlighting those edges by if you look at this option, this will highlight, or this will toggle if you want to highlight the open edges in magenta or in purple or not. So in order to find the open edges, go to geometry doc, in diagnosis doc, select non-manifold edges, and you have also set the option to select non-manifold vertices. And non-manifold edges you may not find. I find non-manifold vertices which are nothing but just a vertex which is connecting, which is kind of joining another vertex, another plane. So you have selected non-manifold edges and you say find. It will show all non-manifold edges under problem triangles. You can select those and show with boundary neighbors. Again, showing with boundary neighbors helps you give look at the problem areas along with certain neighboring triangles, helps you give the perspective in what area of the geometry you are looking at. Also, at the same time, if you may want to hide some of the parts of the geometry, which will help you kind of understand, okay, how exactly these errors are being created. So you should always use view options along with this in order to see how your intersections are being created, and that will help you to address those intersections. Normal orientation, as it's shown before, these are the wrong orientations of the normal. Say this is a typical example. Say if you have a flow path and airfoil, this is how the normal orientation should look like. Everything should point towards the fluid domain. Say from the outside, the domain, the all normal should point towards inside, towards the fluid domain, and then the airfoil surface should point outside, means it's essentially pointing towards the fluid domain. So the way I will remember it, not inside or outside, but towards the fluid domain. Again, these defects are critical. You must address it before, otherwise CONVERGE will complain in the runtime. And these are defects which I typically fix in the last, which is the easiest to fix. The way to toggle the normals is you on the left vertical menu, you have this triangle with a normal. You can select or unselect that, and it will toggle the normals. Normals will be shown by yellow arrows. And again, if you want to see what's the triangles affected by normal orientation, you can say select normal orientation, find, and it will show all triangles is affected by normal orientation. Again, you can show it just the triangles or along with the neighbors. Now, I've discussed all the critical defects. Can briefly go over what are the non-critical defects. And aspect ratio is one of them. It's it's the way it's defined. If it is a triangle which is distorted aspect ratio, if the area to the ratio of area to the summation of square of edges is less than a user specified value, say 0.01, and you can put that number, and it will still show all triangles which satisfy this criteria. Again, all the triangles which are affected by this would be shown under aspect ratio. You can see these triangles, and or you can show along with their boundary neighbors. Again, these problem triangles would be highlighted in magenta. Also remember that these is not important to address to fix a bad aspect ratio triangle. Converge Solver is very robust in addressing in handling distorted aspect ratio triangles. So it's even if you see some, it's you can choose to ignore it. It should not create a per runtime penalty or any other issues. Now the other non-critical defect is a small area. Small area triangles typically would create sometimes an issue in flagging if your triangles which are very small, which may not be needed. So if you want to remove them, that's why typically I would find small area. So triangles with small area. So if your geometry is of order of say 10 centimeters, you may not want a triangle which is 10 raised to minus 8. That does not really add much value by putting this resolution, unless you are looking at very tiny features in the geometry. So it's a non-critical defect, and it's not important to fix them. If you would like to find it, select small area, put up a value for the area. Again, CONVERGE Studio is unit agnostics. CONVERGE Solver always accepts everything in meters. So make sure you have converted everything in meters in CONVERGE Studio, and then you put the number in that unit. And once you have done that, it will find all triangles which have an area less than this value. Small angle, it's again a non-critical defect. Small angle typically would create triangles which we call it as sliver triangles. These are long triangles which are small angle, and sometimes if this angle is very small, it might end up creating edges which create facetting on the surface. So sometimes you may want to do a global stitch to remove remove these small angle or sliver triangle. And the way to find them is to select small angle. You can put an angle here and you find, and it will show all triangles which are affected by small angle. Select them. Show these triangles are shown with boundary neighbors. Overlapping triangles are again non-critical defect. It's if it is angle between two triangles is less than a certain value, say 2 degrees, 3 degrees. Anything less than 5 degrees is a default number, and so if it becomes 0, this will become an intersecting triangle. So, but this is something that that is good to look at, because if you have say a surface, a triangle which is big, and you have another triangle which is making a small angle, say 2 degrees, and if you don't want to resolve the gap between these two triangles, then you may actually want to delete them, right? Because if you don't want to resolve this, it will create bad aspect ratio cells when you are running convert. So if you don't want to keep these gaps, you may want to search for these overlapping triangles and treat them appropriately. You want to delete them, if you want to resolve them, add some proper embedding in those locations. The way to find that is, again, select overlapping triangles, find, and you will see once the overlapping triangles are shown, say select and show, or show with boundary neighbors. Isolated triangles, again, a non-critical defect, and typically these arise because of flagging issues. If you are flagging something and you were not able to pick a certain triangle and it was left behind and it was flagged to certain other boundaries, this will create an isolated triangle. And typically the common assumption is that it's highly unlikely that one single boundary will constitute a triangle. One single triangle will constitute a boundary. So that's great. You can search for isolated triangles of certain group sizes. You can make 1, 2, or 3 in group sizes, and it will show up all bunches of isolated triangle in those groups. And you may want to fix the flagging of these isolated triangles. And the way to do that is quite simple. You can go to flag and say, you can show isolated triangle, and you can put your group sizes and you can fix those and say, I will create something here. Say if I say create this, or say create this, I will flag it to not assigned. So this becomes an isolated triangle, and say find. You'll see I have one isolated triangle, and you say fix isolated triangles. It fixes this isolated triangles. If I had a bunch of 2, and if I say find, it will. Oh, sorry. If I had a bunch of these 2 triangles, let's say 3 triangles, and if I had said fix isolated triangle 3, so it actually flagged it to the round boundary. I can boundary fence. Say if I fix it to faster. Okay, so you can use these ways to fix your isolated triangles. Now, once you've talked about surface defects, we need tools to clean those surfaces, surface defects, and we'll talk about these tools in detail here. And the purpose of these to fix the critical and non-critical if needed. And where do you find these tools? These are available under Geometry Dock, under View or Geometry Dock, or you can get in the shortcut keys Control G. On same hand in hand, it goes in the Objects toolbar. If you remember, that's a pick tool which you use to pick up entities. These two tools together are you will use to fix defects. And the steps are pretty simple. Is you select a cleanup action in the Geometry Dock, say delete, and then you have in your cleanup action, you have chosen that what entity type you want to act on. Then you select that entity type, either vertex, edge, or triangles from the Objects toolbar, and then you select those entities from using the selection options in the Objects toolbar. Then you go to Geometry and you pick up your entities, and then you pick up those entities using the pick tools and apply. It will finish that cleanup action, and then if you want to go back again and you want to repeat this process, and you have finished all the cleanup actions. Again, remember, these are not meant to be CAD tools. If you you want to change something important in the geometries, you want to recreate your sorters, these are not meant to do that. So this is, if your geometry is really looking bad, then we do have some advanced tools to clean up, but sometimes it's better to go back to Studio, go back to a CAD model, and see if you want to address some problems there, and then export the cleaner ST out. So I will start with Geometry Dock under Repair. Under Repair, Delete, you will see different types of delete options. You can delete vertices, edges, or triangle. You can delete any of these, and let's talk about deleting deleting triangles. So if you want to go to Repair, if you want to delete, go to Repair, delete a triangle. I can pick up triangles by boundary fences and say apply. I can delete this. I can always undo. I can pick up triangles any. I can delete them, and the reason I will have deleted them because if there were some intersections issues. Under stitch, you can stitch. You can stitch two vertices. It will merge first vertex to the other vertex. You can patch open loops. Like in this case, I can show if I've deleted boundary fence. If I've deleted this, then if I've created a triangle here from 3 vertices, 1, 2, 3, and I can go to Repair, Patch. By open edge, I can patch. So let me create one more, and I can use patch open edge. I can use this. You see, remember the error, make sure that you are selecting the right entity and say apply. So it says pass this loop, and this triangulation does not really make a difference. Although these triangles are going this way, as long as this is a path surface, we are very happy with that. Triangulation really does not affect the performance of Converge solver or creating the mesh. Compress does stitching, but on a global level. You specify a tolerance, and it will stitch all vertices which have distance less than this tolerance. Then you can create different entities. I already talked about creating some certain geometry shape. You can create triangles from 3 vertices. So you can pick 3 vertices and apply. So it will create triangles. You can sweep edges. You can select a set of edge and you can sweep it along a direction. You can specify a sweep amount and a sweep vector, and it will create triangles sweeping that length. Then you can create triangles by lofting edges. I've used that when I'm creating the swirling dump combustor. You can loft, say, these 2 sets of edges. Say, so this is part of say one of the cooling hole, the primary holes. And these dilutions, say these triangles were missing. We could have used loft edges to create these. You have to first select the first set of edges and the next set of edges, and it will create by lofting these 2 triangles. Remember that the edges are stored in a loop, and the way this is triangulated, it will try to it will look at the first edge. It will start it will have the first edge in that array, and it will try to triangulate from the first triangle in the second array. But it's important to make sure that you cannot start stitch triangulating from here to here. We want to make sure that we triangulate from here to the shortest distance, and that's where the auto matching S chain comes handy. Is that if you select that, it will try to pick up the edge which is the closest distance, and it will try to auto match that, and it will try to triangulate from that location. So auto match S chain is sometimes handy. Sometimes it creates a problem. It depends. If you really don't want to stitch to triangulate to the nearest neighbor. And in that case, it's loft directionally useful. In this case, you don't want to create triangles from here to which is the closest one, which is this edge. You want to align triangles along a particular direction. In that case, loft directionally is useful. In this case, we use first set of edges. You select second set of edges. You specify on top of it a line vector, and it will use that to find the closest vertex along that alignment. And you can also, once you've created these triangles, you can choose to pick them place them in a certain boundary. Under the same create triangles, you can also refine edges. Say if you have selected an edge, and you can specify refine. So if you have one, you say refine five segments. It will add those refinements. And remember that refinements which will not create an additional curvature. So if you have a faceted triangle, faceted circle, it is not going to smoothen or coarsen this. It is going to just create triangles on straight sections, or more refinement on straight sections. So don't use this if you want to create a smoother curvature. This is only to create more triangles. So sometimes it's useful if you want to use that as a precursor to more advanced geometry operations. You can also create individual edges by selecting 2 vertices. If you go to vertex option, you can create individual vertices by a specified location. You can create vertices in middle of 2 vertices, and sometimes useful if you want to make certain measurements. If you want to see if where this spark location was, so I can create a vertex as at the center of a certain geometry. I can translate it along certain direction and make that measurement. So because that's how I know that its spark is located at a certain distance from this face. So this will help me to find what's the location of the spark or location of the embedding should be. So this sometimes comes in handy if you want to make some certain measurements. If you want to If you want to add coordinates for adding monitoring points, this also comes in handy. You can create some coordinates and you can use that to measure where exactly you would like to add your monitoring points. You can also create geometries by copying triangles. You can copy triangles, edges, or vertices. When you're copying it, you can offset it by distance, delta x, delta y, delta z. If you are creating triangles, and then you will also have an option to assign it to a certain boundary. Then if you copy it, if you don't check that, it will by default assign to boundary ID 0. Otherwise, it will go to the assigned desired boundary. You can also create shape. We did discuss about creating basics, creating a cylinder shape under the same option. You can also create other shapes like sphere, boxes, or a bank. This is used for IC engine application. You can also create some basic 2D shapes, rectangles or circles. There are also measurements operations. These are for making some basic measurements in the geometry, which is sometimes useful if you want to say measure the area of an outlet or inlet. You want to measure the volume. You want to calculate the volume flow rate. You want to measure the distance between two vertices. You can measure direction, radii, radius of holes. So there are a bunch of options available for making different basic measurements in the geometry. So this way you don't have to go back to CAD model to make these measurements. There are basic transform options available, which are translate, rotate, scale, and again, standard definitions apply. You can also mirror geometry, and the normal is transformation for orienting the normals so that points towards the fluid domain. Again, all these standard definitions, this will apply towards the geometry. Essentially, you can transform, you can apply towards the entire surface, selected triangle, selected vertices, or a selected boundary. Additionally, you can apply these transform operations to different, if already set up the case, to different embedding, injectors, sources, monitor points, or monitor points of supercycling. So that other things you have set up the case, it also rotates with the geometry, if you would like. So once I've done that, once you've done all your cleanup options, typically you will go to boundary flagging. You may want to flag even before your cleanup. This will help you to hide boundaries so that you can visualize the inside guts of the geometry, so that fixing some of the errors is easier. So in order to do that, so you go to boundary flagging, and you can create different boundaries, and you can flag it as did for our swirling drum combustor. And again, remember, for that we used our boundary fences a lot. To recap, boundary fences are temporary boundaries. These can be removed manually or automatically. And again, once you use fences to flag triangles, pick triangles and flag them to desired boundaries. So once we have talked about different tools, it's time to talk about different cleanup processes. So I will talk about the cleanup process by using a sample NASA LDI combustor. I will be using our diagnosis doc. I will be using a entity toolbar. I will check for different defects. I will try to fix different problems. And the steps, as you have seen, is very standard. Is you go to the diagnosis doc, you select what defects that you're interested in. Make sure that you have selected all the critical defects, intersections, open edges, non-manifold, and normal orientation. And you select those, and you find you will find those defects. And so once you have run those, it's important when you are when you start cleaning those, you make sure that you have found your boundary fences. You can go to geometry, boundary, find clean. This will help you to hide unhide boundaries easily. You can do you can look at the whole geometries, and you can look at the defects all at the same time, or you can isolate your defects by going to that defects and showing with boundary neighbors, or just isolating the defects. So these are the different different intersections. These are different ways to clean the defects. What in rather I will do is I will show this in Studio. So I've taken up a geometry and I have certain defects in the geometry. And the first thing I will do is, see if my geometry diagnostic doc is not open. I will either click the stethoscope to open this, or I could have gone to view, geometry doc, sorry, view, diagnosis doc. I don't want to hide my geometry doc. Diagnosis doc to hide or unhide it. Okay, so again, this is just a toggle, and I've selected all my all the defects I'm interested in: intersections, open edges, non-manifold edges, overlapping triangles I'm not interested in, bound normal orientation, and right now I will uncheck the isolated triangles, say find. So I have all sorts of defects, and most of them are, say, open edges. Say if you want to say show with boundary neighbor. Okay, so it has shown all the defects, all the problem triangles along with the boundary neighbors. Or I could have said show, it will only show triangles which are affected by this defect. Now it's difficult to visualize in this way. That's why using the show with boundary neighbors is the most common. And if you don't want to see these problem triangles, you can do clear and press escape, and it will if you show with boundary neighbor, if you want to, if you press escape, it will remove the selection. This way you want not really, visualization is not problematic. Now I see that what's the problem here? These triangles are missing, so I will go to create, say loft edges, and I will pick up edges by open edge, this edge, and then go to second set of edges, apply. I've created these triangles. Then for this one, I will select this, then go to the next, select this, and apply. This will create these sets of triangles. Now this is an open edge which is creating a hole in the geometry, right? So I can do multiple things. I can go to repair, patch, or I could have gone to create triangles from 3 vertices. I can create now. Make sure that you see, if I selected my open edge, it selected everything. I want to create triangles from 3 vertices. In that case, I want to pick triangles by any 1, 2, and 3. Apply. I could have gone to repair, patch, and so now I'm seeing that free edge loop. I can select, selecting edges by open loop and say apply. It will patch all the triangles here. Now since I've already flagged it, now it's easier to look inside the geometry. You see how if I want to look inside the geometry, if I had not flagged it, it would have been tricky. Or I could have done this. Triangle by boundary fence, I could have selected these 2 and right click and the hide selection. Now I can look inside the geometry. Okay, and now you see these faces for again are missing. I can again go to create triangle, loft edges, apply. So I've created these 2. Again, the same thing here. Apply. And one of the things I want to show here is, say one of these, say there's a hole missing here. And really, if I want to see what exactly this was, I can go to triangle, and if I click on a triangle, or I can click on a triangle and say right click and say list geometry, it will tell me under message log this belong to boundary ID 6, or I can click on triangle and it will show my which boundary it belongs to. You see, this will move to the right boundary. So okay, this is boundary 6. I can show okay. So if I did that, you see, I'm trying to rotate geometry, rotating what's a different point. I could have selected this triangle, or triangle, and right click and view at. So this will allow me to rotate about that point. Okay. In this case, I've set up some injectors. I can go and selectively hide those injectors embedded regions. This is an option to do that. So I will look at this geometry closely here, and if I see that certain part of this geometry is missing, of these cooling holes are missing, what I can do is I can go to repair, delete triangle, and I can delete these cooling holes. Say apply, delete. Okay, so now I've deleted the cooling holes. Now it's time to recreate them. Okay, so if I show this the whole triangles, it becomes a problem. So what I can do is I can do a box select like this and say only isolate, so that I can only see the problem, the triangles I'm interested in. I want to create triangles between these two. Okay, so I want to create triangles between these two loops. So I can go to create loft directionally. I will pick up triangles by, or pick up edges by open edge, and I will go to second set of selection, apply. And you will see that one of the problems it will create is that the triangles are twisted, and this happens because of the auto match edge chains. And in this case, it's good to do this, and we specify a direction. So first we'll go to measure. We'll make some. We will measure direction between two vertices, so that we can specify a direction, preferential direction for lofting, and we'll do that. And this is printed here. I can do right click, select this. This triplets will go to the coordinate cache, copy, and I can go back, create triangles loft directionally. I can paste it here. This becomes available, and second set, apply. And now this creates a triangle in a proper way. So no, this is how you use loft directionally, and so they are different. If I do show all, and what else is left behind there? I think there is again there's one more lofting I could have done, and this. And if I say go back to diagnosis, I will find again all these one open edge. I can show with neighbors. One is left. I can go to the repair, patch, open edge, patch it, and clear, find. See, the only problem left is normal orientation. I can go to transform, normal. I can triangle, say apply. It will fix all the normals. I can go to show all, and it will show me all triangles, and I can check the normals. They are pointing outside. I will do it again, and all normals are pointing inside consistently. Okay, so if I go back to diagnosis, clear, find, it will not create any problems other than to flag these two correct boundaries, in which case we can go to flagging and fix the flagging. So I've discussed most of these, so I will skip these. So when you're doing intersections, most of the time, if you are intersecting, I'll try to typically do is delete the intersecting triangles and recreate them either using a patch loop, or I will create triangles one at a time. The same for non-manifold. If you encounter non-manifold edges, in this case, what I've done is I've deleted those triangles, and I've created them either using patch or creating one triangle at a time. And as I've shown these, you can definitely use lofting triangles to create triangles which are missing. I've shown this when you have some of the cooling holes which could be distorted. You can delete that cooling hole, and you can recreate them by lofting with a direction. You see, if you did not use a loft directionally, you will end up these kind of triangles. just a twisted cylinder. In that case, it's we'll go to loft directionally, and you will measure a direction, and we'll create triangles by using a line vector. If in this we have shown these that if you want to loft these two edges, we'll use standard loft operations. Whenever you have triangles missing, there are few of them, you can either patch them or create the triangles. And then lastly, we'll fix the triangle normals. Sometimes the convention, remember, is that it's all normals should point towards the fluid domain. If you say one click, if everything is pointing outside, one more click should make sure that triangles are pointing towards inside. So at max 2 clicks. So so that's all kind of summarizes what are the different options available for in Studio for a detailed geometry cleanup. There are some automated tools available. The tools in geometry, there are tools available under geometry surface healing. Under this option, these are some of the automated tools, and also there are other tools which are available under Polygonica. These tools are which are available on the surface. They are faster, but they have limited functionality. They may be useful for repairing special types of defects, but they do not have the full functionality. The tools available under repair create, they have the full functionality. They can help fix almost all types of defects. But sometimes the defects may be too many, and in that case, you may have to go with another type of tool which is available in Studio. Although there is a separate licensing needed for that. It's under Polygonica. I will briefly talk about that. So if you're on the repair surface, they have different options available. The first one is remove duplicates. If you have triangles which are overlapping on each other and they are kind of duplicate triangles, it can help to remove those. If there are a bunch of open loops in the geometry, it can help patch all holes in the geometry. It can also help swap long edge in an effort to remove intersections. Sometimes if you just swap the long edge, it will help remove some of the sliver triangles, and it will remove some of the errors. And this is done iteratively in the fixed crease options, in which it will try to swap edges or collapse edges in a smart way so that to remove creases in the geometry. Essentially, it will use it to remove some of the sliver triangles if they are created along the cooling holes in a gas turbine combustor. So let's talk about a bit of some of the advanced geometry tools, and these advanced geometry tools are available under Polygonica, and some of them are available under the surface options. Polygonica can do healing, Boolean, or coarsening. A separate licensing is required. A standard Studio license will not activate Polygonica. Under geometry surface, you have a similar coarsening, surface wrapper, periodic boundaries, and fixed sliver triangles available. These are standard Studio options, and the standard licensing will activate these. Again, all these tools are described in detail under in advanced surface preparation. So if you're in Polygonica, you'll see coarsening, Boolean, or healing operations. So if you want to use coarsening, it will you have to understand why exactly and when do we need coarsening. Coarsening is needed when you have a large number of triangles, say more than 1 million triangles, and that may affect the runtime. So coarsening, I would rather put it optimizing the number of triangles. Sometimes geometries are created from other tools because they were created a certain way, because the way the volumetric mesh is generated in other softwares is through propagating the mesh from the surface inside the domain, the volumetric region. CONVERGE does not do that. CONVERGE, the methodology is different. We only use the surface to trim the volume mesh. So surface triangulation has got nothing to do with volume mesh created. So on a flat surface, 2 triangles is enough. You don't really need 1 million triangles to represent a flat surface. So in that case, sometimes we do, in that split, we do coarsening to optimize the number of triangles. It definitely helps in reducing the The runtimes, if the number of triangles is large, I would say they're larger than 1,000,000. Other than most of the cases are less than 1,000,000 triangles, so it should not really affect much runtime. Coarsening could be based on minimum number of cells. You can specify minimum number of cells, that target cells, or a maximum error. Also, coarsening sometimes removes certain types of error, because the way that Polygonica works, if you have certain errors, if there are holes in the geometry, if you have some intersections, coarsening would also remove that. So you may want to use coarsening as in a way to remove some of the intersections. So now, the same coarsening options is also available under surface coarsening. This is similar to Polygonica coarsening, but this has an additional functionality and an additional restriction too. This tool works best if you want to coarsen boundary by boundary. So if you have flat boundaries, if you want to coarsen one boundary, this surface coarsening tool is very useful. This can help preserve the exact boundary interface. That means it will not coarsen the boundary interface. That means your coarsening would not coarsen your adjoining boundaries, which is sometimes useful, and which is not something that you can do with Polygonica. So that's an added advantage here. But the Polygonica coarsening is more robust, and it helps remove some intersections or some other problems with geometry too. Again, this surface coarsening is based upon two options. You can either specify a target number of cells or a maximum error between the old and the new surfaces. Is when both options are selected, coarsening will stop as soon as one condition is satisfied. Under Polygonica, we have another option for healing. So healing is, as the name says, it's for healing the geometry. If you have intersections, non-manifold edges, it will try to remove them in an effort to create an error-free geometry. You have an option to select fixed intersections, fixed bad orientation. I think we should keep that on all the time. There's an option to keep all cells or keep the largest shell. Shell is nothing but a connected geometry. For gas turbine combustors, typically everything is just one shell because everything is connected. But if you have a case in which there are multiple disconnected surfaces in geometry, in that case you may want to keep all cells. Or if you want to remove something which is not really connected, then you can just keep the largest shell. In Polygonica, when you're doing the healing, you can heal for individual boundaries, or you can heal the whole geometry. When you're healing the whole geometry, you have an option to you can have an option to provide what are the smallest area of triangle that you want, and what's the overlapping triangle tolerance, and this will try to remove any triangles which is less than which create an overlapping triangle less than 5 degrees. So this will kind of heal the whole surface with additional two criteria. Now in Polygonica, we also have Boolean operations, and Boolean, a standard Boolean, you can do union, intersections, a difference, or a section. I will go over this quickly. I will use this Boolean example. So if you have a cylinder and a sphere, they're intersecting. You can create this. You can try this in Studio if you have a Polygonica license. If you have these two, and you can perform different Boolean operations. Say if you do a Boolean of union, that it will remove the inside part of the sphere, and it will create a union of these two surfaces. If you do an intersection, which is in this, it will preserve only say half of the sphere. If you do a difference A minus B, depending what surfaces you we choose at A or B, it will create either this surface or this surface. So it will subtract B from A. Now, Boolean operation section cut. This is operation which is very useful. If you have a combustor which is a full combustion, if you want to create a section, if you want to create a sector, this would be very useful. You can define a plane, and you can create a section out of it. So if I am going to repair Polygonica, and if I want to do a Boolean, and if I want to do a section, I have an option to define a section which defines the plane, and this will help cut a section, and so you can create cut two sections, and you can create um, you can create a plane. You can create a sector geometry out of those. So now we have some of the specific tools available inside Studio for fixing fixing issues which are common in gas turbines. Say one of those are periodic boundaries. So periodic boundaries in Converge need to be planar. So if you have this is a sector case I'm trying to show. These are the two periodic faces, and these two faces have to be planar. It means that all normals should point towards one direction for each face. They should have exactly same triangulation. And for this, sometimes these two triangles, these two planes, they do not have exactly same triangulation. One of the ways is to create a copy of this, rotate it around, and bring it here and stitch with, delete the old triangles here and stitch with the casing here. But that's an additional step, and that's cumbersome. So, what this surface periodic boundary does, it will do that step in an automated way. And that's option available under surface periodic boundaries. So you can choose a boundary to copy, and you can choose a boundary to replace. And copy a boundary, you will say if you have two periodic faces, you will choose one of the periodic faces to copy and choose another periodic face to replace. The one that is to be replaced, that will be deleted, and the copied face would be copied around, and it will stitch back to the original geometry. So this is a very handy tool if you want to create periodic faces. The other restriction for periodic boundary is to have it planar. Say the first face they want to copy is not really planar. You can look at the normals and say one of the normals are not really consistent. It's pointing towards some other way. You may want to make it planar before you want to copy it around. Right. So in that case, either you can just copy this boundary, or if you really want to make this planar, the option available under repair surface periodic is to make a surface planar, and then you select the original geometry, and then you say apply, and it will. This is how to make it. It will change the orientation so that the whole surface will have all normals pointing in the same directions. So there are certain best practices available for CAD surface preparation. You can definitely have your geometry prepared in CAD, and if you have intersections, you can fix it in using the standard geometry tools. You can use Polygonica to fix them, or some of the surface. There's some the tools available in the surface cleanup. But if there are, if you follow certain best practices when you're exporting the STL file from CAD, then it will be then you end up actually having a better STL to start with. So when you're creating the surface, increase the resolution in the areas of sharp curvature. If you have small holes, if you have geometries which are changing, which have a tiny sharp curvatures, make sure that you add resolution in those areas. When you're looking at have cooling holes in the geometry, make sure that each hole is represented by a sufficient number of vertices to avoid cylindrical shapes that will essentially look like prism. So add enough resolution on circles. This will help in creating in having cooling holes which look much nicer. This will also make sure that you verify the solid is watertight. So that you end up not having open edges when you export it. If you have solids in the geometry, and if your simulation just needs an aero volume, it's better to do a subtraction when you're doing the CAD. So if you can subtract your geometry so that you can extract the aero volume. Extract the aero volume and export just the aero volume. If you export the geometry with your solids, then essentially you may end up deleting a bunch of triangles, which you can do. You can do that easily in Studio, but it will make your life easier if you export just the aero volume. So also, most of the STL export operations allow some sort of tune. A knob which you can use to is to control how many triangles you want to put in your final export geometry. You may not be able to put the number of triangles, but you can see that how much resolution you want. And remember that you don't really need a larger resolution because your volumetric mesh generation has got nothing to do with your surface triangulation. Surface triangles only trims the volume mesh, right? And this is a different methodology. So as long as you're happy with your surface resolution, that's more than enough. That's being said, if you have a flat surface, you just need 2 triangles. I mean, or how many triangles you may be needing. Like say in this case, this is enough. You don't really want. I can go to create refine triangles, boundary fence, and this representation is enough. I don't really need. I don't really need a million triangles to represent this surface. So in that spirit, make sure that you have optimized the number of triangles, and this will help in setting up converge cases, and helps keep the triangle which is in the desired limit. So with this, I would conclude my presentation. I will take up a few questions. I would also like to point out some of the following webinar series. This is listed on our website under events online. This will be this is first in a web series. The next one would be on February 14th. This would be on premix combustion, and I will take it in sequence. Then I will discuss about non-premix combustion. I will follow with FGM combustion model. I will talk about how to set up FGM cases for both premix and non-premix cases. Then I will take up a steady state, how to set up steady state flows. And if more people are interested, I'm trying to do, I can do more in this online training. So every 15 days. So the next one, remember, is on 14th at the same time, Wednesday, 9 to 11. And this I'm going to discuss the setting up premix combustion case using entitlement rate. So I'll take up a few questions, and definitely feel free to put your questions in the question box. Only Converge employees can see those questions. I will try to get back to you as soon as possible. Also, I'm always available. Feel free to drop me or Scott a note, and we can answer your questions or follow up your questions individually. So one of the questions I see is if I can talk briefly about a CVG file, DAT file, and an STL file in Converge. Okay, so this is a good question. So whatever I was doing here, it seems to be complete. So I've created a bunch of triangles. So this is what I'm trying to show is these many triangles representing a flat surface is not really needed. You may some software may need to create these many triangles to populate the volumetric mesh. So this is in the spirit that you may want to coarsen it. In that case, what I would have done is created a boundary fence and then go to repair, delete triangles, and I've deleted these triangles, and I would then I will create this using loft edges. Okay. So the question was is is there DAT file, STL file, and a CVG file? Remember, when you export from a CAD model, you get a STL file, and this is the most common starting point. is that when you have nothing, you have just exported a geometry from your CAD model, you have an STL file, and you will import that in CONVERGE Studio. And then once you're working in CONVERGE Studio, so either I can wait. Let me launch my studio again. So when you're working CONVERGE Studio, the first thing you will do is to import STL. And say in this case, say if I import Swara geometry, and you will start working with it. And once you start working, you can save it, save as, and you can save it as a CVG file. This is your intermediate file. This is only used by CONVERGE Studio, and this cannot be used by any software, neither the CONVERGE solver. CONVERGE solver needs the .in the .dat files, okay, which you will export from here, okay. And when you can also export this as a surface file. And the surface file, when you export it, it's different from STL. It's an ASCII file. It has a different way of representing triangles. It just picks up the vertices, the coordinates of the vertices, and the connectivity information. And this is what you will use. This is what you use by CONVERGE solver. So STL file is your starting point. CVG file is an intermediate project file, and DAT file is what eventually would be used by CONVERGE solver. Although you may have an option to import a surface file directly if you have one. If I have one, I can import a surface file directly. Okay, I think we have already at the end of our webinar here. There's one more question asking if I can go over the Polygonica Boolean operation very quickly. So I can quickly create two shapes. If I create a sphere, okay, I can create a cylinder, okay, and I can go to boundary flag. I can create two boundaries, and I will pick by boundary fence. Say if I put to boundary 1, I will put this to boundary 2, and I can let's to create a cylinder slightly bigger. Okay, we go to boundary 2, and then I can go to repair Polygonica, say union. So I can select boundary 1 and boundary 2, apply. So it will create a union of these two. If I want to create a section, I can provide a section like this, and if I say apply, it creates a section this direction. If I choose the section to be normal along X, it creates a section like this. So this is very useful when you want to create a section out of a geometry. And I say for full combustion, if you want to create a section, this would be very useful. So I think with this, I will conclude my webinar. Again, thanks for joining. I will pass it on to Scott if you had any question.
Yes, thank you very much, Gaurav. As those of you who have a chance to see, Gaurav's quite skilled at this geometry manipulation and cleanup. So please do, if you have any other questions, please do let us know. We did have a good series of questions that were asked during the webinar or online training, and we look forward to seeing you for the future online trainings. Don't worry if you missed one in the series. You'll still be able to focus in on whatever specific online training you're interested in, although we do encourage you to listen to them all. So thank you very much, and have a great day.